Hello guys, I'm Saish from Calling Cops. Today we are so glad to present you our project on spam call detection. The scope of our project is to focus on how to reduce the time cost and to speed up the system to detect the spam calls by implementing the various concepts and algorithms of HPC. Firstly, let me introduce you what is HPC and how it is used in our digital world. HPC is also known as high performance computing. It is well known for its computing capabilities. In a nutshell, it is about solving larger problems in various fields like science, engineering, and business at higher speeds. It is very useful for simulating test scenarios which are used in designing new products and healthcare industries, and to solve complex problems through parallel computing rather than traditional serial computing. Our project objective is to detect voice over internet spam calls for better user experience and achieve this by implementing parallel computing libraries like PIMP, joblib, multiprocessing, which we used in our machine learning algorithms. We also compared parallel execution with serial execution with the help of visualization to check the performance of our algorithms. Methodology. Initially, the multiprocessing library is used to parallelize the training task of 3 machine learning models. The training time is decreased when compared with training models one after the other. With KNN algorithm, we tried to parallelize the prediction task on the test dataset. We conducted different experiments with different number of processors ranging from 1 to 8 and also presented an analysis of all 3 libraries.
The first part of the project. In the first part, 3 different machine learning models are trained parallelly by using multiprocessing library. The logistic regression, random forest, decision tree, all 3 models are trained parallelly on 3 different processors at a single time. When compared with the training of these models one after the other serially, the parallel execution of these models, parallel training of these models took very less training time. Here you can see the 3 different models and the parallel execution of these models. In the second part, we performed different experiments with 3 different parallel libraries: multiprocessing library, PyMP library, and joblib. Let us start with the first library. After importing the dataset, we performed some data pre-processing. Here we used KNN, and since the KNN algorithm training time is order of 1, we tried to parallelize the testing of the KNN algorithm. We tried to reduce the testing time. Here, by using the multiprocessing library, we parallelize the test dataset. So hence the testing time can be reduced with the help of this multiprocessing library. When conducted different experiments with the number of different processors we got different different testing times. Here you can see the different testing times. Performing the similar experimentation with PyMP library, we also got different testing times. Here you can see the PyMP library implementation, and the same with the joblib. All these 3 libraries are performed, the experiments are performed similarly with all these 3 libraries. You can see the entire comparison of these 3 different libraries, the testing time in the PPT.
Here is the visualization of the observations we made in our project. There are 2 plots with time taken on y-axis and split value on x-axis. As we can see, the 2 different plots are plotted to visualize the performance of the data when number of processes used to predict the task are 2 and 4 respectively. We employ different modules and libraries to analyze the performance of the algorithm. The modules we used are serial IP, VOIP, and joblet. In each plot, we have two scenarios where the split value is 0.5 and 0.8. We observe that the time taken to complete the task through serial computing is relatively higher than other two modules. Whereas in case of joblet, we observe that the performance is more optimized and also the time taken to complete the task is comparatively lesser than other two modules. This is the comparison of time taken by three different libraries to perform the task. On y-axis we have time taken, on an x-axis we have number of cores used. You can see that by increasing the number of cores we use, the time taken decreases. The time taken to perform the task is inversely proportional to the number of cores we used. By our research, we found out that the joblet is optimized to be fast and robust, in particular on large data, and has specific optimizations for NumPy arrays. We observed that the joblet library is consistent in nature and the overall time cost is lesser than the other libraries. We also observed that the PYMP and multiprocessing libraries, when employed by one processor, takes more time to perform the task, but as the number of processors increases, the time cost drops drastically. Here is the average plot which shows us the overall performance of these libraries. These are the results of our project. When compared with parallel execution, serial execution takes more time. Number of processes is inversely proportional to the time taken for execution. More the processes, lesser the time taken for execution. Initially, joblet performed well, but as the number of processes increased, PYMP outperformed joblet.